Okay, here's the question then. I've got it summarized over the page. It's a long question. This is a sketch of the curve with a minimum at R. Then we've got parts A, B, and part C. This is part C. Okay, so I've got it all summarized here on one page. So x coordinate of Q lies between 2.1 and 2.2. The root lies between there. So A, we need to work out the y of 2.1 and y of 2.2, don't we? So input these values into x. 2 cosine 2.1 squared over 2 plus 2.1 cubed minus 3 times 2.1 minus 2, isn't it? Just putting in the 2.1. If we put in 2.2, hopefully a change of sign will occur. That's what we want to demonstrate here, to show there's a root between those two values. Minus 2, so put 2.2s in instead of 2.1s for the x's. So it's 2 times, I'm in radians mode, 2.1 squared divided by 2 plus 2.1 cubed, and then it's minus 3 times 2.1 minus 2 minus 0.22, which is less than 0. Now we put in 2.2 in, so let's toggle back and change those values, 2.1s to 2.2s. 2.2, I think there's 3 places, 2 and there, 2.2, 0.54. Change of sign. So root lies in between. So root lies between. Okay, good. That's part A. Done that. Part B, show that the x-coordinate of R is a solution. Show that the x-coordinate of R, the minimum, is a solution of this. Okay, well I'm just going to go back and check the thing to check I wrote it correctly. Okay. X-coordinate of R, so that's when it's a minimum. So y is equal to 2 cosine x squared over 2 plus x cubed minus 3x minus 2. I've just written it down from here. Now, change the sign, show that the x-coordinate of R, so dy dx, let it equal 0, will be the minimum. It's the local minimum, isn't it? So cos of something goes to minus sine, 2 lots of, sine of something, multiplied by the something differentiated, that's 2x over 2, which is just an x, which I'll put there, plus 3x squared minus 3. Okay. So, what we can do here, okay, we can get the 3x squared, leave the 3x squared as is, and move these to equals 0 when 3x squared is equal to 3 plus 2x sine x squared over 2, or in other words, x squared is equal to 1 plus 2/3 x sine x squared over 2. We just had a look at what we needed to get, and we rearranged it accordingly. So square root both sides, then x will equal the square root of 1 plus 2/3 x sine x squared over 2, which is what we wanted to obtain. X is positive because in the diagram it shows that X has a positive value here. This minimum has an X positive value. Okay, good. Okay, so that's what we've got there for part B. So we've done that. So using this iteration formula now then, x0 is 1.3, find x1 and x2 to 3dp. So x to the n plus 1. Okay, x0 is equal to 1.3. We want x1 and x2 to 3dp. So let's put it in the calculator then. We've got the square root of, oh, cancel. We'll put 1.3 in the calculator first, in ants. Okay, so we got the square root of 1 plus 2 divided by 3 times sine of ants squared divided by 2, close bracket. That's what we got then. Equals 1.224. 19. We needed to work them out to 3dp, I think. 1.224 to 3 decimal places. And we've got ants in as this now, so we just press equals again. 1.2058. 1.206, and that was the 3 decimal places. There's our x1 and x2 to 3 dp. Yeah, I've just managed to get this last part wrong. Just check the solutions now, simply because I didn't enter this xn in the calculator, so I missed that off when I did the calculation. So I'm going to do this part again now, just briefly. All this is wrong now, so I'll see I've missed the xn, the 1.3 to start with in there. So let's do it again then. So let's put 1.3 in as our starting point. That's the xn. Then it's the square root of 1 plus 2 divided by 3 times, and then it's 1 answer times sine. Get it right in a minute. Answer squared divided by 2, close bracket, outside the square root, equals 1.283, 2838, 2838, 838, which is 1.284, isn't it? So 284. I'll edit that better in a minute. Let's do the next one. 1.27600, 1.276, which is 1.276. So let's just change that to an 8 and this to a 7. And those are the answers to 3dp. Apologies for the error in not putting that term in the first place in the calculator.